So tangent of 21.8 degrees is 0.399, let's say 0.997 equals x over 800. Put that over 1 to make it a proportion. I cross multiply and I get x equals, and 0.39997 times 800 is 319.98, and this is in meters. All right, let's take a look at example number 2. Example number 2, a ramp is 120 feet long and rises vertically 15 feet. Okay, so let's see. A ramp rises vertically. Let's see, a ramp is 120 feet long, so my ramp is 120 feet. Rises vertically 15 feet. Okay, so if here's the ground down here, and if my ramp rises vertically 15 feet, then this distance here is 15 feet. Find the angle of elevation of the ramp. Okay, well, angle of elevation is this angle between a horizontal line, and if I think I've got an observer down here looking up to the top of the ramp, then this is my angle of elevation. And my angle of elevation, oh, let's see, that's what I'm looking for. So I want to find this angle. I've got the opposite leg, and I've got the hypotenuse. So I want the trig ratio that uses opposite and hypotenuse. That's going to be sine. Now I just fill in the values from my triangle. Sine of what angle? X equals opposite, which is 15, over hypotenuse, which is 120. And since I'm looking for an angle, I'm going to use my inverse sine. So I want inverse sine of 15 over 120. And the inverse sine of 15 over 120, if I punch that into my calculator, I get 7.18 degrees. Okay, angle of depression. The angle of depression is just an angle, again, formed by a horizontal line. And a line of sight looking down. So here we've got a picture, and again I've got this hot air balloon that's up here in the air, but notice that in this picture my observer is standing in the hot air balloon. They're not down on the ground. So my observer is up here in the hot air balloon, and they're looking down at this object that's down here on the ground, this bag of money. All right. Now, the angle in this case, my angle of depression, notice an angle formed by a horizontal line. In this case, my horizontal line is not the ground. In this case, my horizontal line is this kind of imaginary line up here at the hot air balloon. And my line of sight, now I'm looking down, so my angle is the angle formed by this horizontal line and this line of sight. This angle here is my angle of depression. Now, one thing to notice about angles of depression and angles of elevation, sometimes you see these angles, they're actually in the same picture. So, for example, if this were an angle of depression, this would be an angle of elevation, and if both of those angles show up in the same picture, well, it turns out that they're always going to be congruent, because this horizontal line and this horizontal line, they're parallel, and here I've got two parallel lines cut by a transversal, which you may remember means that these two angles here have got to be congruent. Turns out that's a very handy property of angles of elevation and depression. We're going to see that being used here in just a minute. All right, so let's take a look at these examples using angles of depression. Example number 3. From the top of a lighthouse, an observer notices a boat and finds the angle of depression to be 12 degrees. Okay, so I need a lighthouse. Here's my lighthouse. I've got an observer standing up here on top of the lighthouse. And an observer notices a boat. Okay, so here's the ocean. And here's a boat. Observer sees a boat and notices the angle of depression to be 12 degrees. Okay, so if my observer is looking down at the boat, my horizontal line is going to be this horizontal line up here, and my angle of depression is the angle between that horizontal line and this line of sight. So that's this angle right here. So that angle is 12 degrees. And let's see what else we have. The boat is 900 feet from the bottom of the lighthouse. So that's this distance right here. So this distance is going to be 900 feet. What is the height of the lighthouse? So we'll call that x. I'm looking for the height of the lighthouse. And now I notice that if I assume this is my right angle right here, I'm assuming that the lighthouse is standing straight up and down. It's not leaning. So I've got this right triangle. And this angle right here, I notice it's not part of my triangle, but if I remember that this angle and this angle here must be congruent because I've got parallel lines cut by that transversal. So then this angle here is also 12 degrees. And now I can see if this is my selected angle, I'm looking for the opposite leg. I've got the adjacent leg. I'm going to use my tangent trig ratio. Tangent is opposite over adjacent. Now I can just fill in the information here from my right triangle. Tangent of what angle? 12 degrees. Equals opposite, which is x, over adjacent, which is 900. And again, I punch tangent of 12 degrees into my calculator. I get 0.2126. That equals x over 900. Again, I've got a proportion. I can cross multiply and solve my proportion. 1 times x is x. And 0.2126 times 900 is 191.34 feet. All right, example number 4. The angle of depression of a car from a hot air balloon basket is 40 degrees. The balloon is directly over a water tower that is 5 kilometers from the car. Okay, so let's see. I've got a hot air balloon. My hot air balloon is directly over a water tower. So my water tower is down here on the ground. And let's see, I've got a car. The water tower is 5 kilometers from the car. Okay, so my car is over here somewhere. And let's see, the water tower is 5 kilometers away from the car. So this distance here is 5 kilometers. And my balloon is directly over the water tower. And I'm told the angle of depression of the car from the hot air balloon basket is 40 degrees. So if I've got an observer up here in the balloon looking down at the car, and the angle of depression is 40 degrees, so then the angle of depression, I remember the angle of depression is an angle between a horizontal line and this line of sight looking down, so this is my angle of depression, 40 degrees, which means that this angle down here is also 40 degrees. And let's see, I'm looking for the direct distance from the balloon to the car, which means this distance right here, the direct distance from the balloon to the car, that's going to be x. In other words, I'm looking for the hypotenuse of this right triangle. And again, I'm assuming this is a right angle. I'm assuming my water tower is straight up and down. So let's see here. I've got this angle, I've got the adjacent leg, and I've got the hypotenuse. Adjacent over hypotenuse is cosine, so I'm going to use cosine. And let's see, let me fill in my information. Cosine of what angle? 40. Adjacent is 5. Hypotenuse is x. And let's see, cosine of 40 degrees. If I punch that in, I get 0.7660 equals 5 over x. Put that over 1. And now if I cross multiply, 1 times 5 is 5. 0.7660 times x, and if I divide both sides of my equation by 0.7660, then I get x equals 6.53, and let's see, this is in kilometers.